Hello and welcome to Microsoft Hates Greg. My name is Greg Deckler, and today we're going to be talking about refresh speeds in flat tables versus star schemas. Now, if you recall, I initially had refresh speeds for as a pro for star schemas, right? So in my initial test with my 100 million row fact table, I think the flat fact table refreshed in like 30 minutes, and the star schema refreshed in like 20 minutes or something like that. If I recall correctly, I'd have to go back to the video and actually see what the numbers were, because I think I had it in my Excel spreadsheet. Now, but then I realized, oh, I'm an idiot, and I'm taking a star schema and flattening it to a flat table in Power Query and breaking query folding. And I'm thinking to myself, that's not a valid test, right? Um, I should take a flat schema into a flat schema and a star schema into a star schema, right? With minimal transformations, all that sort of stuff. So what I did is I took and materialized this 1 million row fact table right here. And this is the SQL I used to do it, right? Now, and if you're before you ask, yes, it's out. This flatten.sql is out in the flat star schema directory, right? Everything I do. So I did this and I retested the star 1 million and the flat 1 million pointing to this table instead of, the original table and then collapsing it and doing all the joins and stuff. And it turned out to be, it was the same. It was like 16 seconds. It was right around there for both of those. So I was like, okay, it's the same, right? There is no difference in terms of refresh and that sort of thing. So, that was the conclusion I reached later. Then I published one of my videos out, and one of the comments came back from a Hilla Galapo. Sorry if I murdered your name. But and she was mentioning about refresh speeds and that flat tables are tremendously slow, at like 80 million rows and that sort of thing. And so I'm, like, well, I tested that and I didn't see a difference, but I didn't test it at 80, like at that level of magnitude, right? At the 50 million row kind of level, order of magnitude. So I'm like, well, I'll retest it and make a video on it. So this is that video. And I think it's some interesting results and cautionary tales and all of that sort of stuff. So let's get in. So again, so what I did was I took that same script and I ran it for the 50 million row and did that. Now, my initial tests on this, right, between flat 50 million and star 50 million, right? Let me bring it up here. So when I initially tested this, and let's zoom in on this. So now I've tested this and did the flat 50 million, right? It took 7 minutes and 20 seconds to load the rows. So that's when the fact table, the counter on the fact table stopped, okay? And then, there's always this processing that goes on, and I'm assuming that's it building the data dictionary, blah, 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 right? So it ended at 12 minutes and 8 seconds. All right, for the star 50 million, it took 5 minutes and 45 seconds to load the rows, and it ended after almost basically 10 minutes. So you're talking about a 2-minute difference, which is about a 20% difference in terms of the actual overall load times. So, I mean, nothing to really crow about. I mean, it's not significantly, slower and that sort of stuff. But then I decided, well, but Greg, I better double check, right? And so I did, and I found a problem. So I wanted to make sure that these were all native queries, right? So native query, right? View native query, all those are active. View native query, yep, view native query. And then I got to this one and it's not. And the reason why it's not, in that when I originally basically scaled up the AdventureWorks databases, the dates didn't come over right? So for example, if I go back to here and I come over here, like the ship date, the due date, and the order date are all null. And I wanted those to be filled in, okay? And so I removed the columns and I inserted 3 date columns that I basically recalculated the date off of the order date key. So this became a problem, in my opinion, because I basically failed the other way. I fixed the flat table, right? But now I've got a bias going the other direction, right? And the reason for all of this is because I didn't originally even think about testing refresh times with star versus flat. It was always all about the DAX. And I wanted to test whether the DAX is faster with the flat versus the star. So I didn't really ever think too much about the refresh and the queries and all that stuff involved. So my bad, right? That's that's why we need transparency when doing this stuff, so that other people can try to replicate what you do and then point out why you're an idiot. Okay, that's how this should work. So what I did is I created another star schema, and of course that doesn't work because teams and blah blah blah. I created this one. And this one is not perfect either, because I just removed all those steps, which means that it's not really loading the same information as the flat table, which has these filled in, right? It's going to be probably more efficient in loading, that sort of thing. So, but I went with this and I tested this out. So, and this was more, I think, more accurate in terms of than what I was doing before. And so here, right, this one took 2 minutes and 30 seconds to load the road, significantly faster, and it took 6 minutes and 46 seconds until the end. So you're talking about like half the time, right, in terms of the overall load time versus the loading up the flat table, right? Overall, almost 50% faster. Now, the interesting thing I found in this, though, is that the overall time is really mostly in loading the rows, right? Not in the overall processing of creating the indexes and creating the data dictionaries and all of that stuff, that post-processing after everything's loaded, right? In the case of the flat table, it's just under 5 minutes, right? In the star schema, 50 million, right? You're talking about it's like 4 minutes. It's over 4 minutes, right? And in the star, 50 million refresh, again, it's over 4 minutes. So that's not where the primary difference is from. The primary difference, in my opinion, looking at the numbers, is the biggest difference, the 2 minutes and 30 seconds versus 7 minutes and 20 seconds, right? You're talking, it's not 4 times, but it's three times faster, right? Versus the overall load time is less than, 50% faster, I guess you could say. So yeah, I mean, but there is, and so you could complain about these dates not being filled in with doing this, but I could probably, fix that and write some SQL and fix all that kind of stuff, but I'm not going to, because I'm willing to concede the point that a star schema is going to refresh faster than a flat table, and potentially by a significant amount. Okay. Now, whether or not that matters a hill of beans is up to, I think that's a matter of perspective and use case, to be honest. Like, do I care if my 50 million row table refreshes in 12 minutes versus 6 minutes or 7 minutes, right? Maybe I care about that, right? Maybe once it scales up to 100 million and it's talking about 15 minutes versus 30 minutes, maybe I care then, but maybe I don't, right? Maybe I'm only refreshing this thing once a day, and I don't care that it takes 30 minutes or 15 minutes, right? Or it's like, oh no, I need to refresh this at least 2 times an hour, and then it becomes important, right? So, but is refreshing a star schema faster than a flat table? Yep, it is, and you start to see that around the 10 million row kind of mark, if you will. Anything below that, it's so fast that it doesn't even really matter. From what at least in the testing in this scenario, right? You're talking 16 seconds, or maybe it's 17 and a half seconds or something like that, right? It's so fast that it doesn't matter at all. But at the level of 10 million rows, 100 million rows, and past that, it definitely becomes something that you should think about, right? So again, this is why we need transparency when doing benchmarks, because it's easy to screw it up, right? We can all make mistakes in this, right? So it's important not to just pay lip service to the fact that we need transparency with benchmarks and repeatability and all that stuff. You actually need to do it, okay? So that is all I had for this video. Hope you enjoyed it, and I'll see you next time.